Okay, so yesterday, I need to correct myself, by the way. I was tripping. I was running on 2.5 hours of sleep, but I got sleep last night. Boom, boom, boom. 7 hours. Yeah, 7 hours of sleep. Yeah. So I call this guy Sigma, and I have no clue now that I look at it why I said Sigma yesterday. This is a whole lowercase alpha.
I would just go with
And
it.
no one changed it or said, Miss Jones, what's wrong with you? Y'all just let me make a fool of myself. No one. Yeah, it's a lowercase alpha.
Okay.
And yeah, thanks for fixing me yesterday.
Sorry.
Yeah.
I thought you knew what you were doing.
No, not in that moment. All right, it doesn't matter. I'm still human. And sleep. Do you know that lack of sleep can almost be equivalent to being drunk?
Yes.
I had 7 hours. I'm good. I'm good. Okay. Root beers. Got it. Here we go. All right. So key thing we talked about yesterday is reference angles are going to always be positive, right? Reference angles are going to always be positive because it's just asking you how far something is. And as we've learned before, distance is positive, right? If I'm walking backwards and I'm going to say, I just walked -3 miles today. No, I'm not. I just walked 3 miles backwards. Okay. So yesterday we stopped at, we did the degrees. Now we're going to do the radians, right? Okay. So our first radian up is theta. We did 7. Oh, perfect.
But you can do it real fast.
Okay. We had theta is at 4 pi over 3. And we decided that what quadrant was that in? 3. It's in quadrant 3. We go, pew. Okay. All right. Reference angle is describing how far is it from its nearest x-axis, right? Nearest x-axis. So when I look here, my nearest x-axis is 180, which is pi, right? And so we have 4 pi over 3. And I want to know how far is it from here to here? So from here to here, how far is it?
Pi over 3.
Pi over 3. That's because 4 pi over 3 minus pi equals pi over 3. Okay? If you're doing it and you're like, how did they get pi over 3? Remember, this is a 1. And as long as the numerator and denominator are the same value, it still equals 1, right? And I can just subtract straight across. All right? So here is my alpha, my reference angle. Okay. Now we're at pi over 6. And I think we talked about how, now it's all coming back to me. Pi over 6, we were like right here. There's my theta, right? And my nearest x-axis here is 0. So if that's my nearest x-axis, what is my theta? Oh my gosh, my theta equals, my alpha equals my theta, right? So it's just going to be pi over 6. It's just like on a number line. I ask you, how far is 4 from 0? 4. You're going to tell me 4, right? So if you ask me an angle, how far is pi over 6 from 0? Pi over 6, ma'am. Pi over 6. Okay. All right. So on the next part, what I want you to do is to take a moment and try to make a generalization of if an angle is in quadrant 1, what would you do to find its reference? If an angle is in quadrant 2, what would you do to find its reference? No, like how would you find it? Like how would you calculate the reference angle? I want you to tell me what you would do. Okay. If I'm in quadrant 1, how would I determine the reference angle every single time? No matter what the angle is.
Well, 0. Minus your closest x-axis says at 0. Just
Okay.
its value.
It's just its value. It's close to 0, so therefore I'm using this angle. And because I'm using that angle, that means that alpha just equals theta. So if it's in quadrant 1, your reference angle equals your theta, whatever your theta is. Does that make sense? So for example, if I said theta equals 4 degrees, what is my reference angle? 4 degrees. Yes? All right.
Wait. Is your theta the highlighted section?
What's the little squiggly thing that's equal to 4?
That's
It's-
her weird,
Oh, with the line.
oh, that one, that's her alpha.
My theta got a little weird under the normal. Let me try.
Oh, yeah. there-
You see how slow I have to do that?
That's just
Why
like-
you
that's-
put a line?
That's just like.
Like it's still on the paper.
Because I don't like how it looks that way.
It's just. it's
Okay.
almost like X.
All right, my theta and then my alpha. All right. Look here, guys. I will work on my calligraphy. Here we go. Now, if I'm in quadrant 2, what is my nearest x-axis?
Either 180 or 5.
Either 180 or pi, right? So to find my reference angle, so I'm just going to write the word reference. So to find my reference angle, what am I going to do?
80 minus theta.
180 minus theta. Or what? Or pi minus theta. Yes. So for example, if theta equals 175 degrees, what is my reference angle? Oh no. Somebody, everybody scream.
What's every
Thank
five?
you.
5.
5. Because in quadrant 2, what are you doing?
I feel like this class just like one big inside.
No,
All right, yeah.
I don't know.
It's okay.
What's not?
All right, quadrant 3 again. My nearest x-axis is 180 or pi, right? What do I need to do to find the reference angle? What am I doing here? Do what? Subtract from 180? Subtract 180. So it's your theta minus 180. In reality, yes, because okay, which also, or it could be theta minus pi. Okay, what if I had, so let's say I had theta equals 5 pi over 3. Nope, too high. And y'all were just gonna let me make that fool of myself again. Gosh, guys. Because I realized I was in the wrong spot. We already did this, by the way.
I should make it up for him.
Yeah,
Yeah.
Oh, it's pi over 3.
we just did it. I was like, come on, guys, we just did it. Okay, so it'd just be pi over 3, which we already did, right? That was our example on 7. Is that correct? Yeah. Okay, now, if I'm in quadrant 4, my nearest reference angle is
360 or negative 2 pi.
or positive 2 pi
Oh,
also.
positive, sorry, yes.
Yeah. And so therefore, to find the reference angle, what would I need to do?
I did it.
The reference angle would be 360 minus my theta, or 2 pi minus my theta. Okay, now, these only work if your coterminal is between 0 and 360, right? I mean, if your theta is between 0 and 360. If your theta is not between 0 and 360, then you're gonna have to find its coterminal angle, which is why we learned coterminals first. So yes, so for example, if we had theta equal 390 degrees, is 390 degrees between 0 and 360? No, so we would need to find an equivalent coterminal angle. Does that make sense? To find its reference angle. So we would need to find its coterminal that would be between 0 and 360. And what would be the coterminal for 390 degrees? Okay, remember to find coterminal, it equals the number either plus or minus 360, right? So my coterminal here would be 30 degrees. So the angle that I would use to find my reference angle would be 30 degrees. Does that make sense? And 30 is in quadrant 1. So therefore my reference angle equals 30 degrees. Okay. Oh, that's my 1 for quadrant 1. My Roman numeral. Okay, so this is just saying these rules apply if your theta is between 0 and 360 or 0 and 2 pi. If not, I have to find its coterminal in order to use the reference angle. Got it? All right. All right, so that concludes our reference angles.
Boo, boo.